Hi guys, welcome back to my channel Ace Education. How are you guys? I'm good. Hope you are doing well. Before starting my video, every time I'm telling you, focus on your revision. I think you have 5 to 6 weeks left for your examination. Today I'm going to teach you solution and the concentration. Let's start the topic, guys. I don't want to waste the time. Let's start the topic. Solution. Anyone? Any idea about the solution? What is meant by the term solution? It is a homogeneous mixture of two and more than two components. It is a homo mixture of two or more than two components. Let's see what are the components. So it is a homogeneous mixture of two and more than two components. What is the meaning of homogeneous? Look at the homogeneous. Homogeneous mixture of two or more than two components. What are the components? Solute and solvent. Mostly we think that solute is a solid substance and solvent is a liquid substance. That's not the case. Solute is one which we use in a small quantity, always in a small quantity. So this is small quantity. And solvent is one which we use in a large quantity, Small quantity and large quantity. Solute can be, look at the solute. Solute can be solid, liquid, gas. Same thing, solvent can be solid, liquid, gas. Now come to the homogeneous. Before I will teach you what is the meaning of homogeneous, let's do some small kind of activity. Let's take 2 grams of common salt, NaCl, and I want to dissolve this 2 grams in 100 centimeter cube of H2O. Yeah, can you tell me which one is a solute, which one is a solvent? As I discussed, the small quantity would be a solute. So 2 grams of NaCl is my solute and 100 centimeter cube of water is my solvent. So solute would be in a small quantity and a solvent would be in a large quantity. Now the homogeneous mixture. I want to dissolve it, and after dissolving 2 grams of sugar in 100 centimeter cube of water, use the stirrer and stir it. What happened, guys, when you stir it? Obviously 2 grams of NaCl dissolve in 100 centimeter cube of water. So I have a solution here. You can't say solvent and you can't say solute. When you look at the solution carefully, you cannot differentiate solute and the solvent. They look in a one phase, like a single phase, either in a solid phase or a liquid phase or a gas phase. You cannot separate them out without disturbing it. I mean, when you heat it, you can, but without heating, you feel that it's look like a one solution. It look like a one system. That is meant by the term homogeneous. Homogeneous meaning after mixing solute in the solvent, it will be completely dissolved and you will get a one single phase. They appear as one phase. Okay. Now, when you combine these solute and the solvent, you will end up with 9 types of solution. I don't want to go in detail. We will definitely get 9 types. So I will give you one more activity. Figure out 9 types of solution with example. Okay, guys. Now, we know what is meant by the term solution. So it is a homogeneous mixture of 2 or more than 2 components. One is solute, one is solvent. Okay. How can we express this solution? Any idea? How can we express this solution in terms of strength? How can you explain the strength of the solution? We can express the strength of the solution as concentration. So we can express its strength in terms of concentration, and the old school, they still use the term molarity. That's why it's called molar solution. But for AQA at Excel and OCR, I'm using the term concentration. So we will learn what is meant by the term concentration and how can we use this concentration to work out the strength of a solution. Okay. Molarity and concentration is the same thing, but I don't want to go in detail about a little difference, small difference. I don't want to discuss here. Let's focus on the concentration term. So what is meant by concentration of a solution? Okay. Concentration, the short form is conc. Conc of a solution is nothing but number of moles of a solute or any chemical substance present in 1 dm cube of its solution. So it's easy. Can I use the C? C is for conc. Concentration is nothing but number of moles of any chemical substance, which is nothing but solute, divided by its volume. The volume should be in dm cube. So conc or C, conc equals to mole over volume, or conc equals to N over V. Use this formula, copy down this formula. We will use this formula in many cases or in many questions. Conc equals to mole over volume. So what's the unit of conc? Conc equals to, unit for mole is mole. What's the unit for volume? dm cube. So mole per dm cube, mole per dm cube. That's the unit for conc. Whenever in the question you will see any number like 0.5 mole dm minus 3, meaning this is the concentration of the solution. How can we recognize that's the mole, that's the volume, that's the dm cube? So if you look at this unit, mole dm minus 3, it means this is the concentration of a solution. Okay, we will do some questions based on this chemical formula. Okay, guys, let's start. Some question. Do you want to copy that one? Okay. Okay, I will write the formula one more time. Don't worry. I'm sorry about the space. Hopefully, soon I'm going to buy a large or big boat, or otherwise the interactive boat. Let's see. Just pray for me so that I can buy a white interactive boat. Okay. So conc equals to mole over vol. Concentration is nothing but number of moles of a solute present in 1 dm cube of its solution. Let's do some small question. Find the concentration of 6.3 gram of HNO3 dissolve in 250 centimeter cube. Make sure, guys, this whole in always dm cube. Whenever you will get centimeter cube, first thing you have to do, convert in dm cube. Okay, mass is given, but in the formula we have volume. So sorry, volume and a mole. So how can we work out the mole when the mass is given? You know that. How can we work out the mole when the mass is given? Mass divided by its mr. So mass is 6.3 and mr of HNO3, hydrogen 1, nitrogen. Look at the AR of hydrogen 1, nitrogen 14, oxygen 16 times by 3. You can get the AR from the periodic table. When you work it out, it is 6.3. So, it's 63. 6.3 divided by 63, which is 0.1 mole. Go back to conc. Conc equals to mole over wall. Mole is 0.1, volume 250. That's 250 centimeter cube. I have to change it into dm cube. So I want to divide it by 1000. So some students, they are doing A-level maths. They know how to do it. Anyway, it's not a big calculation. Take this 1000 to the upper side. So 0.1 into 1000 divided by 250. So let's cancel by 4 times. So what's the answer? 0.4. And what's the unit? Mole dm minus 3. So this is the way we can work out, or we can crack the question based on concentration. I want to give you one more question. Let's see. Now, write down one more question. What's the chemical formula of sodium carbonate, guys? Anyone? Okay, don't worry about the formula. I will teach you the formula, how to write the formula. Na2CO3. Okay. Find the number of moles of 0.5 mole dm minus 3 Na2CO3 sodium carbonate. You can write the word sodium carbonate, but I want to use sodium carbonate chemical formula. It's easy for me. I can save my space. Dissolve in 250 centimeter cube. You want to try it? This time conc is given, and we have to work out the mole. So C equals to N over V, or N equals to CV divided by 1000. When you are writing the chemical formula, make it in a box so that when you do the revision, you know what's the formula to work out the mole. So mole equals to C times V over 1000. Do we have a conc? Yes, conc is given. 0.5. What's the volume? 250 divided by 1000. Why I'm dividing by 1000 here? Because the volume is given in centimeter cube. I have to convert into dm cube always. Look at the standard unit of concentration, mole per dm cube. So 0.5 divided by 4. So 5 over 4 into 10 to the power of minus 1. You can use the calculator and work out how much is that. Is that okay? Can we do one more question? Agree? Okay. Okay. I think it's 0.125 volts. We can do one more question. Find the mass of 0.2 mole Dm-3 calcium carbonate dissolved in 100 centimeter cube. You want to try it? Okay. C n equals to C times V over 1000 to work out the mole. Because I have conc and volume. Okay. N equals to C how much? 0.2 times 100 divided by 1000, which will give me moles. So cancel. 2 into 10 to the power of minus 2 or 0.02. 0.02 is the mole. How can we work out mass when the mole is given? Oh, sorry, mole is not given, but you work it out. Okay, mass equals to mole time its MR of calcium carbonate. How much is the mole? 0.02 times 100 calcium carbonate. Take calcium 40, it's AR, plus 12 plus 16 times 3. In some periodic table, AR of the calcium is given as 40.1, but I'm not taking 0.1. So 2 gram. When you work it out, it's 2 gram. Okay. Can we do one more question? Can I rub the question? Is it okay? Okay, one more question. No. See, first I want to write the equation. Calcium, that's the question, guys. Don't get confused with that. Okay, sorry. Look at that. I want to write the equation, chemical equation. Calcium carbonate react with hydrochloric acid to form calcium chloride plus water plus carbon dioxide gas form. Is that equation balanced? Nope. Times by 2, now it is balanced. Now, I'm keep on telling, don't worry about the balancing of the chemical equation. I will teach you when I will start redox reaction and balance the chemical equation. Okay, now find the mass of CaCO3 when 0.2 mole Dm-3 250 centimeter cube of hydrochloric acid reacts with some X gram of CaCO3. Again, it's a combination of concentration question and a kind of stoichiometry. Okay, one more time. Read the question. Find the mass of calcium carbonate, X gram of calcium carbonate. When 0.2 mole DM-3, 250 centimeter cube of HCl react with some X gram of calcium carbonate. Okay. Directly, masses or mole is not given for calcium carbonate. But with the help of the stoichiometric ratio, we can work out the mole. So first, figure out the actual mole of HCl by using this information. By using this, now look at the concentration of hydrochloric acid is given and a volume of hydrochloric acid is given. Can we work out the mole of HCl? Yes, why not? So mole or N, mole instead of mole, use N. I showed you just now. N equals to C times V over 1000. So my sir told me that understanding a question is an art. Once you understood the question, it's easy to work out. So look at the question and try to write down the information which is given in the question. So we have conc of HCl and a volume of HCl. Look at that. So work out the mole. It's easy to work out the mole of HCl. N equals to 0.2 times 250 divided by 1000. Again, 1 over 4. So 2 divided by 4 into 10 to the power of minus 1. So 1 time, 2 time. So 0.5 into 10 to the power of minus 1 or 0.05 moles. Agree? One's two's yeah. So we got 0.05 mole of HCl. What's the theoretical ratio? 1:2. And we got so CaCO3 versus 2HCl. I got 0.05 mole. Yeah, you have to work out the mole of CaCO3 first. So mole of CaCO3 is nothing but 0.05 divided by 2. Is that okay, guys? Yeah, so we have to divide this by 2. Okay, then. Now, can I write 0.05 like 5 into 10 to the power of minus 2 divided by 2? To make your life easy, the best thing is that you can use the calculator. So 5 divided by 2 is 0.5 into 10 to the power of minus 2 is the mole of CaCO3. With that mole, can I work out its mass? Yes, why not? Mass of CaCO3 mole time its MR. We got the mole. Can I write here? 0.05 mole we got it into 10 to the power of minus 2. MR of calcium carbonate is 100. So again, this cancel. Mass equals to mass of CaCO3 equals to 2.5 gram. You can expect this type of question in your examination. So please practice this type of question. I want to stop here. I will continue different type of concentration question in my next lesson. And in my next lesson, hopefully, I want to start titration. And after that, we will do percentage impurity. And after that, I want to teach you number of water molecule attached to unknown substances. Then, if time permits, I want to teach you back titration. Back titration is the very important titration. I've seen in many past paper, whether it's AQA, OCR, or Edexcel, we will definitely get one back titration question. What's the purpose of the back titration and how can we solve question based on the back titration? Thanks, guys. And please one more time, I'm requesting you to subscribe my channel. Thank you so much. Bye. Guys, welcome back to my channel, Ace Education. How are you guys? What's going on? You know, I've already started one video on the concentration, and let's continue some numerical question based on the concentration term. Look at this question. I'm going to read the question. A solution of sodium hydroxide had a concentration of 4 gram dm cube. What is its concentration in mole per dm cube? It's just a conversion factor. We will do how to convert mole dm per cube to gram dm per cube. Okay, look at this formula. You can see my previous video to figure out this formula. Conc equals to concentration equals to mole over volume. Okay, mole in terms of the mass. Mole is nothing but mass over its mr. So plug the same mass over mr here. So conc equals to mass divided by mr, which is mole. 1 over vol. Okay, is that okay? Yeah. So bring that mr to that side. So conc time mr equals to mass divided by volume. How you measure the mass? Mass is measured in terms of gram. Okay, gram. How you measure volume? Dm cube. So bring that dm cube to that side. It's become gram dm minus 3. So to convert mole dm cube to gram dm cube, we have to multiply conc by its mr. So conc time, that's a short formula, conc time mr equals to gram dm minus 3. What's the given in that question? You have gram per dm cube and you have to convert into mole per dm cube. So in that case, you have to divide this. Conc equals to gram dm minus 3 divided by its mr. What's the conc in terms of gram dm cube given? 4 divided by mr of sodium hydroxide. Mr of sodium hydroxide, NaOH, sodium 23 plus oxygen 16 plus H1, which is nothing but 40. So 4 divided by 40 is equals to 0.1 mole per dm cube. We will do one more question. Is that okay? Is that clear? Can I rub that question, guys? Look at this question. What is the concentration of a 0.05 mole dm minus 3 solution of sodium carbonate in gram per dm cube? So in that question, conc is given in terms of mole per dm cube, and we have to change into gram per dm cube. So look at the board. I have given this formula. Conc time mr equals to gram per dm cube. This time we have to convert mole per dm cube into gram per dm cube. See, look. Conc time mr equals to gram per dm cube. What's the concentration? 0.05 of sodium carbonate. Can anyone let me know what's the formula of sodium carbonate? Okay. Na2CO3, sodium carbonate. If you don't know the formula, don't worry, I will teach you. Sodium 23 times 2 plus carbon 12 plus oxygen 16 times 3. Use your calculator and work out. This is 106. So 5 times 106 divided by 100. How much is 5 times 106? 106 times 5, 35. Look at that. 106 times 5, 530. So 530 divided by 100, I think 5.3 mole per dm cube. Is that okay? Yeah, we will do one more question. So you can change anything from mole dm cube to gram dm cube. The conversion factor is that conc into mr equals to gram per dm cube. Okay. Okay. Look at this question. In that question, we have to work out the volume of the sulfuric acid. Now, what is the maximum volume of 0.5 mole dm minus 3 sulfuric acid needed to react with 0.24 gram of magnesium? It's a kind of stoichiometry and the concentration question. They clubbed both together. Whenever we have a stoichiometric type of question, you have to write it's a balanced chemical equation. So magnesium reacts with sulfuric acid to form what? Any idea? Any guessing? Metal react with acid to form salt plus hydrogen gas coming off. So magnesium, Mg, react with sulfuric acid to form magnesium sulfate. Don't worry guys, keep on telling you. Don't worry about the formula of magnesium sulfate. I will teach you in my future videos. So Mg, for time being, look at the question. MgSO4 plus H2 gas. So what is the maximum volume of sulfuric acid? We have to focus only on these two reactants. I don't want the product. With the help of all these quantity, you can figure out the mole of magnesium. Look at the mass of magnesium given. Use the formula to work out the mole of magnesium. Mole equals to mass by its AR. So 0.24 divided by 24, which is nothing but 0.01 mole. So 1 magnesium, 1 mole of sulfuric acid. Look at the theoretical molar ratio. That's 1:1, guys. Look, 1 element of magnesium, 1 mole of magnesium element react with 1 mole of sulfuric acid. Look at 1:1 ratio, molar ratio. And with this gram, we just work out the mole of the magnesium, 0.01 mole, we got it from that. So, which is also equals to 0.01 mole of H2SO4. So we got the mole. Now we have to figure out its volume by using concentration formula. Conc equals to mole over volume. Do we have a concentration? Yes. Do we have a mole? Yes, mole of the sulfuric acid. And we have to work out the volume, rearrange it. So volume equals to mole over its conc. What's the mole? Just now we got it. Mole equals to 0.01 and conc equals to 0.5. So it's 1 This 0, 1, 0, 1, 0 cancel. 0.1 divided by 5, or 1 over 5 times 10 to the power of minus 1. 1 over 5 is 0.2. 0.2 into 10 to the power of minus 1, or 2 into 10 to the power of minus 2. Guys, I'm really sorry. I have a habit of doing this type of calculation. Don't get confused with that. You can use your calculator to figure out the answer. Okay, let's do one more question. Look at one more question, and it's a type of stoichiometry and concentration based. What mass of barium sulfate would be produced by adding excess barium chloride to 20 centimeter cube of copper sulfate of a concentration 0.1 mole? Okay, whenever I just told you this type of question is given, we have to write its balanced chemical equation. So barium chloride react with copper sulfate to form barium sulfate plus copper chloride. We don't need copper chloride, CuCl2. Is that okay? So what mass of barium sulfate would be formed? So we have to work out the mass of barium sulfate. Look at the molar ratio: 1 mole, 1 mole, 1 mole, 1 mole. And what is provided in that question? We have 20 centimeter cube of barium chloride. So conc of barium chloride is given, which is 0.1, and mole of barium chloride is given, which is 20 centimeter cube. So guys, whenever we have a conc and a volume, the best thing is that you have to work out number of moles of barium chloride. So N equals to C times V over 1000. How much is the conc? 0.1. 0.1 times 20 divided by 1000. So this cancel. So 2 into 10 to the power of minus 3. Is that okay? So that's the mole of barium chloride. What's the molar ratio of barium chloride and barium sulfate? 1:1. What mass of barium sulfate would be provided by adding excess of barium chloride? My bad, guys. That's the barium chloride in excess. So this is the volume. What mass of this is the volume and concentration of copper sulfate, not the barium chloride. Look at that. Barium chloride is in excess. So that says in excess. To 20 centimeter cube of copper sulfate, and a concentration of copper sulfate is given. So I'm writing here CuSO4 number of moles equals to 2 into 10 to the power of minus 3. How? C times V divided by 1000. Conc of copper sulfate is given, volume of copper sulfate is given. So that's the number of moles. So we have to look at the relationship between copper sulfate and barium sulfate. What's the molar ratio? 1:1. Okay. So moles of BaSO4 form is 2 into 10 to the power of minus 3. Is that clear? With that mole, can we work out the mass of the barium sulfate form? Yes, we can. So mole equals to mass over its volume, or mole. Why volume? Mole equals to mass over its MR of barium sulfate. Now rearrange this formula to get the mass. Mass equals to mole times its MR. What mole you got it? 2 into 10 to the power of minus 3. When you work out the mR of the barium, you will get 233. So, which is 466 into 10 to the power of minus 3, or 0.466 gram. We have a unit for the mass. Is that clear, guys? Look at one more question. It's a different type. I've seen this question in OCR past paper and HUA past paper. How to work out the volume of water added. The same solution, look at the same solution. We have one solution whose volume and conc is given to you. Like HCl is a solution whose volume is given to you and conc is given to you. You have to add some water, that I don't know, X amount of water added, so that its concentration changes to this value. Before you adding water, the concentration was 0.5 and the volume was 250. When you add water, the concentration decreases. Why? I will tell you. Look at the formula for this. Is called dilution question. So these questions, we call them as a dilution question. And how much amount of water you have to add to make this concentration or to decrease its concentration. So conc equals to a mole over volume. As long as my solution is same, I mean as long as one solute is there, we can use this formula. So when the solute is same, like my solute or my chemical substance is HCl, I'm not changing HCl. Look at that, HCl is same. When the solute is same, so what's the relationship between the concentration and volume? Inversely. Conc is inversely proportional to volume. What does it mean? It means that when you increase the volume, concentration decreases. It's inversely proportionality. With that, we are getting one equation, C1 V1 equals to C2 V2. Very important equation, guys. Very important chemical formula. You can use this chemical formula when you will get a titration question to figure out the volume of the water added or the volume of the solution added. See, both this relationship is inversely. When you are adding or diluting some solution, its concentration decreases. So we are using the same phenomenon. Okay, so if suppose I will take C1 V1 and C2, we have to work out V2 first. Work out the V2. So C1 equals to 0.5, agree. V1 equals to 250. Now C2, its concentration changes to 0.2. As I told you, when you add some water, its concentration changes because you are diluting the solution. It's so clear, it's so obvious. And V2 equals to how much? Okay, if you don't mind, can I rub this part, only that part? Okay, now look at that. Use the same formula, C1 V1 equals to C2 V2. Okay, in some books it is given as M1 V1 equals to M2 V2 because the molarity and the concentration is same. A little bit difference, I don't want to go in that detail. So C1 V1 equals to C2 V2. How much is C1? C1 is 0.5 and V1 is 250. C2, I think C2 is given 0.2. C2 is 0.2. Look at 0.2, and we have to work out the V2. That's the final volume. This is the initial volume. Initial volume is 250 and the initial concentration is 0.5 mole dm minus 3. When you add X amount of water, the volume increases. So we have to work out the V2 first. V2 equals to, look at that, V2 equals to 0.5 times 250 divided by 0.2. So no point cancel. So V2 equals to 5 times 250 divided by 2. So 5 times 125. Agree? Yep. Now V2, just work out the V2, use your calculator. So 125 times 5. Look, 5 times 5, 25, 5 2s are 10, 11, 12. 5 1s are 5 plus 6, 625. So V2 equals to 625 centimeter cube. I want to work out the volume of the water added. This is not the volume of the water added. This is V2. We want to change to V2. Look at that picture. We have a volume which is 250 and the final volume at 625. How can we work out the volume of the water added? So this much is the volume of the water added. Now please focus on this question. I've seen this question in the past paper of AQA and OCR. So volume of the water added, volume of H2O added equals to V2 minus V1. 625 minus 250. So work it out. How much is that? And I think it's easy. You can use your calculator and then work it out. So whenever this type of question will be given to you in the examination, don't just end up your question after calculating V2. Volume of the water added is equals to, did you get it? Okay. It's 375. Is that okay? 375 centimeter cube per centimeter. Okay. Whenever you will get this type of question, please don't try to end up with the V2. They're not asking V2. Look at the question. Volume of water added or needed. That is V2 minus V1. So guys, I want to stop my lesson here. Please practice those type of questions. Check your past paper based on the concentration and the amount of substances. You can see your past paper of OCR and AQA. It doesn't matter. The content is same. So we will meet in my next lesson. Hey guys, welcome back to my channel, and we will continue our topic of concentration. I've already started this topic in my previous video. Let's continue concentration topic, and I will start some more question based on the concentration, guys. And after that, we are doing some titration questions. Is that okay? Yeah. We will do this question. Look at that. This question is based on when two solutions are going to mix in a big container, how can we figure out the molarity or the concentration of the resulting solution? Look at that. I have a short formula for that, and we can use the lengthiest method, but look at the short formula. Resulting concentration equals to C1 V1 plus C2 V2 over total volume, like TV total volume. This formula we can use only when we have same chemical substance or same solute. Look, we have HCl solution is mixed with 0.2 molybdenum minus 300 centimeter cube. HCl solution is mixed with HCl solution. Then only we can use this formula. So what's the C1? C1 is 0.2 and V1 is 100. Okay. Plus, look at the C2. C2 is 0.1 times 400 divided by total volume, which is 500 centimeter cube. Do we need to change into dm cube? No, guys, because divided by 1000, divided by 1000, divided by 1000, they cancel off. You don't need to change this into dm cube. Okay, this cancel, that cancel, this cancel, that cancel. So 20 plus 40 divided by 500. 20 plus 40, 60 divided by 500. 5 times 12. 12 divided by 100, which is nothing but 0.12 mole dm minus 3. See, always the resulting concentration is less than the concentration of individual acids. Why? Because we are adding more volume. See the concept. We have already done that. Conc equals to mole over wall, mole over volume. When the volume increases, concentration decreases. So the concentration of the resulting solution should be less than the original concentration. Now, I will teach you one more concept that will come up in the examination. Let's see. Look at this question. A new term we are using here. Look at that. A solution of sodium hydroxide had a concentration of 4 gram per dm cube. What is its concentration in mole dm cube? So how can we convert gram per dm cube, mole per dm cube to gram per dm cube? Guys, I have seen this question in many past paper. You can use this technique for AQ examination or OCR examination. Look at that. Mole over concentration. Concentration is equal to mole over volume. We know that. Conc equals to mole over volume. Okay, concentration equals to mole over volume. What is mole in terms of mass? Mole is nothing but mass over mr. So plug all these mass over mr in case of mole. So conc, plug here, conc equals to mass over mr times 1 over volume. Okay, is that clear? Now take conc to that side. Conc time mr equals to mass over volume. Now look at that. Mass we measure in terms of grams, and how you measure the volume? Volume in terms of dm cube. So dm minus 3. So conc time mr equals to gram per dm cube. This is the easy way we can change mole per dm cube to gram per dm cube. So conc time mr equals to gram dm minus 3. Look at the question one more time. So 4 gram per dm cube is given, and you have to change into mole per dm cube. So rearrange this formula. So conc equals to gram dm minus 3 divided by mr. So simple, guys. You don't need to calculate anything. It's just the simple conversion. So what's the gram per dm cube? 4 gram per dm cube. Work out the mr of sodium hydroxide. Sodium 23 plus 16 plus 1, which is equals to 40, guys. So 4 1 1, not 0.1, not 0.1 mole dm minus 3. We will do one more question, guys. Okay, we will do one more question, guys. Look, what is the concentration of 0.05 mole dm minus 3 solution of sodium carbonate in gram per dm cube? So conc, which is given in mole dm minus 3, so you have to change into gram per dm cube. What's the formula? Conc, concentration time mr equals to gram per dm cube. Easy, guys. So concentration is given, conc equals conc time mr equals to gram dm minus 3. Sorry, I have written the formula twice, so it doesn't matter. What's the concentration? 0.05 and mr of sodium carbonate. mr of sodium carbonate, Na 23 times 2, 23 times 2 plus carbon 12 plus 16 times 3. I think it's 106, guys. 0.5 times 106. So 106 times 5, 35. So which is nothing but 53 into 10 to the power of minus 2, which is equals to 0.53 gram dm minus 3. Easy, guys. So we can change conc, which is given in terms of mole dm minus 3, into gram per dm cube. Or if they will give gram per dm cube, we can convert into mole per dm cube. That's the easy way, guys. Yeah, this is another type of question I have seen in many past paper. Now look at one more question. Look at this question, guys. What mass of barium sulfate would be produced by adding excess barium chloride solution to 20 centimeter cube of copper sulfate solution of a concentration this one? So we have to write the balanced chemical equation, then only we can do. It's a kind of a stoichiometry question. So what mass of barium sulfate is formed when excess of barium chloride react with copper chloride? So copper sulfate reacts with barium chloride to form barium sulfate, BaSO4. Look at, it's all one reactant to form one product. Barium sulfate, we are getting barium sulfate, what we are getting? Copper chloride plus CuCl2. Okay, a theoretical ratio is 1:1:1. Now, what data is given in the question? We have 20 centimeter cube of copper sulfate, conc, and volume of copper sulfate is given. Conc of copper sulfate is 0.1 and volume of the copper sulfate equals to 20. When a volume and a conc is given to you, what's the first step? Work out the number of mole of the copper sulfate. What is the formula to work out the mole? Mole equals to C times V over 1000, guys. So 0.1 times 20 divided by 1000. Is that okay? Yes. So 2 into 10 to the power of minus 3 mole. What mass of barium sulfate? We have to work out the mass of the barium sulfate. How much? So moles, 1:1 molar ratio. You got the same mole of the barium sulfate. Work out the MR of the barium sulfate. So mass of barium sulfate is equal to mole time its MR. When you work out the MR, mole is 2 into 10 to the power of minus 3. And when you work out the MR of the barium sulfate, use this barium 137, sulfur is 32, oxygen 16 times 4. So the total is 233. That's the MR of barium sulfate. Now, mass equals to mole time MR. So 2 times 233 times by 2, 4 equals to 466 into 10 to the power of minus 3, or 0.466 grams. Is that okay? Yeah. Can you try this question? What is the maximum mass of calcium carbonate which will react with 25 centimeter cube of 2 molybdenum minus 3 hydrochloric acid? Let's see. First, we have to write the chemical equation between the calcium chloride and the hydrochloric acid, guys. You know, look, this is the general trend. When a carbonate, metal carbonate, react with any acid, we will get salt plus water plus carbon dioxide gas. I will teach you soon how to write the chemical formula of the substance and how to balance the chemical equation. Okay, let's write the balanced chemical equation first. CaCO3 react with hydrochloric acid, and I will tell you that any carbonate, metal carbonate, when react with the acid, we will get salt, CaCl2. Don't worry about the formula of calcium chloride, plus water and plus carbon dioxide gas. So look at the molar ratio. Is that reaction balanced, guys? And look at the how many chlorine? 2 chlorine here and 1 chlorine here. So you have to times by 2 here. My bad. Yeah, 2 chlorine. This is hydrochloric acid and 2 chlorine. Now is that balanced? 1 calcium, 1 calcium, 1 carbon, 3 oxygen, 1 plus 2, 3 oxygen, 2 hydrogen, 2 chlorine. Yeah. Okay. What is the maximum mass of calcium carbonate? Mass is not given. You have to work out the mass. And we have conch of HCl in that question and a volume of HCl in that question. So conch is given, conch of HCl is given, which is 2 mole per dm cube. Vol is given, volume equals to 25 centimeter cube. Guys, whenever we have a volume and conch, the first step, work out the mole. Mole equals to C times V over 1000. CV, mole equals to CV. Because this volume is given in centimeter cube, that's why I divided by 1000. So C 2 into 25 divided by 1000, which is nothing but 50 over 1000 equals to 5 into 10 to the power of minus 2. Is that okay? Yeah. 5 into 10 to the power of minus 2 is the mole of the HCl. Look at the molar ratio. 1:2, guys. So you got 5 into 10 to the power of minus 2. So 1 mole of calcium carbonate react with the 2 mole. So can I divide this by 2 to get the mole of calcium carbonate? So 5 divided by 2 into 10 to the power of minus 2 mole of CaCO3. So 2.5 into 10 to the power of minus 2 is the mole of calcium carbonate. So if you don't mind, can I can I write this part? Only that part of the question. I'm not robbing all. Okay, I have some little space to work out my calculation. So mass equals to mole of CO3 times its MR. What's the mole of CaCO3? 2.5 into 10 to the power of minus 2 MR of calcium carbonate. You can work it out. Calcium 40, carbon 12, oxygen 16, which is nothing but 100. So what's the answer? 2.5 gram. So I want to stop here. Please, guys, I know your exam is coming up only 4 weeks. So do revision of this type of question. You can choose any textbook, OCR, AQA. I don't mind it. And if you have any question, please get back to me. If you have any question based on the concentration or a titration or a back titration, you can get back to me. I will try to help you. So thank you guys for watching this video, and I will come back soon with one more video. In that video, I'm going to teach concentration in terms of titration and a back titration. Important thing, back titration. Okay, thank you guys.